In this lecture, we are going to talk about differentiation. For instance, now the general method for differentiation is if you have y is equal to, let's say, a s n. To differentiate this, what do? You use n to multiply a and then subtract 1 from n. So this becomes a, or let's say n times a. Use n to multiply a, then write x again and then subtract 1 from this. So this becomes what? N a x n minus 1. Now, if we use numerical values, for instance, if you have y is equals to 2x squared. Now what do? It becomes 2 times, use this 2 to multiply this 2, then you write the s, then 2 minus 1. Okay, 2 times 2 is what? It's 4. Then we write x. 2 minus 1 is what? 1, which is what? 4x. So if I give you, for instance, let's try our hands on this, 5s raised to the power of 3. What do? Use 3 to multiply 5, which is 5 times 3, then you write the s, 3 minus 1. So this becomes 15x. 3 minus 1 is what? 2. Okay, now in the same vein, if you are given, let's say, y is equals to s raised to the power of 4, how do you differentiate this? You know that this s is carrying an imaginary 1 here, so this becomes 1s raised to the power of 4. Okay, which is y is equals to, use this 4 to multiply this, the y, the s will be equals to, use this 4 to multiply 1, so it becomes 1 times 4, then x, 4 minus 1. 1 times 4 is what? 4. Then we have s. 4 minus 1 is what? 3. Now if you use this to multiply this, it gives you 4 times 3, then x, 3 minus 1. If you differentiate again, this is 4 times 3 is 12 x squared. If you continue differentiating again, it becomes what? 12. You agree with me that this becomes s, 2 minus 1, which is 12s raised to the power of what? 1, and it continues like that. So in this video, we are going to use this all through. So don't expect me to explain how we got. For instance, I may just give you an equation like this: y is equals to, let's say, 3s raised to the power of 3 plus 2s squared plus 1. Now when you differentiate a constant that is not carrying anything like s or y, it gives you what? 0. Now if you differentiate 2x, for instance, let's say a constant carrying just one variable without no power, it will give you the what? The coefficient here, which is 2. So if I differentiate 3s, it gives us what? 3. If I differentiate 4x, it gives me what? 4, and it continues like that. So if I was to differentiate this, our dy ds would be equals to what? 3 times 3 gives us what? 9. Then we'll have x, then 2 plus 4 what? X. Why? Because what we did is 3 times 3, then we wrote x, 3 minus 1, plus what? 2 times 2, then we wrote s, 2 minus 1. 3 times 3 is 9, s, 3 minus 1 is square, plus 2 times 2 is 4x. And that is the answer to that question. So in this quest, we are going to be talking much or taking much calculation on differentiation using what we just learned now. Let's continue. Welcome to this lecture. Let's prefer solution to the following question. Now the first question here says that given that f of s is equals to 5x minus 12. So let's pen it down. Our f of s was given as what? 5x minus 2. And g of x is equals to s squared. And then h of x is equals to sine x. Now the question says, what is the value, or what is this expression for g of f of h? For g of f of h. Now first of all, before we find g of f of h, let's look at f of h, or f dot h. F dot h simply means multiply the value of f by what? H. So if we take that, f dot h will be equal to, what is our f? F is 5x minus 12 times, what is our h? Our h is what? Sine x. So multiplying this, what are you going to have? You have 5x minus 12 bracket what? Sine x. Now the next thing we were asked to do was to find g of f of h. What does this mean? It means that in g, wherever you see s, put in the value of what? F of h. In g, wherever you see x, normally you are supposed to have g of x. Okay? In g, wherever you see x, put in the value of f of h. Now what is our g? Our g is, or g of s rather, g of s is s square. Okay? G of s is s square. So wherever you see s here, you put the value of what? F of h, or f multiplied by h. So our g f of h will be equals to, we have x here, so we put the value of what? F dot h, which is what? 5x minus 12 sine what? X, everything in a big bracket, there what? Squared. Okay? Everything in a big bracket squared. Now if you multiply this with this, if you use the square to open through, it's going to give us 5x minus 12 square, then sine square x. And that makes option D the correct answer to this question. Now let's take the next question. The next question says, if f of x is equal to 3x plus 20, find the inverse or determine the inverse. Now we said our f of s is also equals to y, so y is equals to what? 3s plus 20. To find the inverse, what do? Make s of the formula. So to make s of the formula, we say y minus 20, that is to say if 20 crosses to this side, come y minus 20 is equals to what? 3x. So our x, you divide both sides by 3. To make s of the formula, 3 cancel 3, and your s is y minus 20 all over 3. Now at this point in time, what do? Wherever you see s, put y, and wherever you see y, put s. So in this place we have x here, so here becomes y is equals to, here you have y here, becomes what? X minus 20 all over 3. So that is the answer. If you want to break this down, it gives us y is equals to s over 3 minus 20 all over 3, and that is the answer to that question. That is option A is the answer. Now to the next question. Now given that f of s is equal to s raised to the power of 3 plus 4s squared minus 3, determine f of minus 1 plus f of minus 2. Now the first thing is to find f of minus 1. F of minus 1 is equals to what? S raised to the power of 3 plus 4s squared plus 3. It means wherever you see s, put minus 1. Okay? Why? Because we initially have f of s, and s has been replaced by what? Minus 1. So wherever you see s, put minus 1. This will be equals to minus 1 raised to the power of 3 plus 4 bracket minus 1 squared plus 3. Minus 1 raised to the power of 3 is what? Minus 1 plus 4 bracket minus 1 squared is 1 plus 3, and this becomes minus 1. 4 times 1 is plus 4 plus 3, and this gives us minus 1 plus 4 plus 3 is 7, and this is equals to 6. Okay, the next thing is f bracket minus 2, and this will be equals to s raised to the power of 3 plus 4s squared minus 3. Now what do? Wherever you see, normally here is supposed to be s, right? It means that wherever you see s, put minus 2. So this becomes minus 2 raised to the power of 3 plus 4 bracket minus 2 square minus 3. Minus 2 raised to the power of 3 is minus 8 plus 4 Minus 2 square is 4 minus 3. And this becomes minus 8 plus 4 times 4 is 16 minus 3. And this gives us minus 8. 16 minus 3 is plus 13. And this will be equals to 5. Minus 8 plus this is 5. So our answer to this question is supposed to be 6 plus 5. And that's supposed to be, I think, 11. Okay, no, yeah, it's correct. 6 plus 5, that's supposed to be 11. Okay, sorry, we made an initial mistake here. Okay, we made an initial mistake here. Okay, and that mistake, let's correct it. Here it's supposed to be negative, so this becomes minus, and at the end of the day you have this minus 1 plus 7 minus 1 here becomes, okay, here becomes 4 minus 1 is 1, so it becomes minus 1 plus 1, and minus 1 plus 1, I think it will give us 0. So here is 0. So we have 0 plus 5 is equal to 0 plus 5 will give us 0 plus 5 will give us 5. So the correct answer to this question is equal to 5 and not the level we got initially. Okay, now let's continue. We have the next question that says, if f of s is equal to the root 4 minus s squared, what is the domain? Now the domain at all input value that will make this everything in the root to be defined, and that value must be greater than or equal to 0. Anything that makes it to be something like root of minus 1, this is what? Not defined. It's a complex number, it's not defined. So that value must be greater than or equal to what? 0 for this to be the domain. Domain are all values that you must put in here to make the equation to be what? Greater than or equal to 0. Now at the end of the day, if you take this one to this side of the equation, what are you going to have? You have 4 greater than or equal to what? S squared. Okay, 4 greater than or equals to s squared. Now for you to find x, you find the square root. So we have square root here, and this will be 2 greater than or equal to what? X. So 2 is greater than or equal to what? X is our domain. Now remember that it is squared here. Okay, so 2 can have negative values. So our correct answer supposed to be, if 2 is greater than or equal to x, it means that x is what? Is less than or equal to 2, and at the same time minus 2 is less than or equal to what? X. And that would be our answer, and the correct answer is option C. Now what does that mean? It means if you substitute int in the range, for instance substitute 2 in, becomes minus bracket minus 2 square. This will give a root of 4 minus 4, and this is root of 0, and this is what? 0 is defined. Okay, now if you put minus 1 here, it becomes root of 4 minus 1 square. That will be root of 4 minus 1, and that is root 3. Is also what? Defined. So all values that this can have, in order for it to be defined, is the what? Domain of the function. So the correct answer is this: minus 2 less than or equal to s, and less than or equal to what? 2. That's our domain. Now let's take the next question. Now what function is this? This is the Heaviside function. Heaviside function. Whenever you have this bracket here and all these values, talking about the Heaviside function. Now the value of the expression is, now the value of the expression given to you is what? Sine 7x minus 5 all over 7x is given us as the limit of x, please take note of that, tends to 0. What can we do in this function? Now we can decide to do something quickly. We can say let's sin x, separate it, so this become over 7s minus 5 over 7s. This is still the same thing as what is up here. We just divided it such a way that 7s belongs to this and the same time belongs to this. Now we know that sin a all over a as the limit of x tends to 0, this is a constant, this equals to 1. So if you have sin 7s, let's assume our a is equals to what? 7s now. Okay, so this is the same as sin a all over what? A, since a is 7s. Okay, if we assume it that way, so this will be equals to what? 1. It means everything here is what? 1 minus 5 all over 7x. Okay, and this will be 1 minus 5 all over 7 bracket. What is our x? Our s is 0 as the limit of s tends to 0. S is 0, and this will be 1 minus 5 minus 7 times 0 is 0, and then we have 1 minus this, which is 1 minus infinity. 1 minus infinity is what? I think it equals to 1 because we don't know that value there. So let's say 1 minus 0. So the correct answer to this question is what? D, which is 1. Okay, now let's take the next question. Is this supposed to be 1? Or let's say it is undefined, because 1 minus infinity. Okay, let's take it as 1. Now let's have this question. It says the limit of s tends to infinity of 2s plus 5 all over s squared minus 7s plus 3. Now whenever you are given a question like this, you divide both up and down by the value or by which of them that have the highest power here. Okay, the highest power here is what? S squared. The coefficient of s squared, so you divide both sides up and down by what? S squared, and this gives us 2x divided by s squared plus 5 divided by what? S squared all over s squared over s squared plus 7x all over s squared plus what? 3. And this cancel this, give us 2 over x plus 5 over s squared divided by this, cancel this, it gives us what? 1 plus 7. This cancel this, it gives us 7 over what? X plus 3 all over s squared. This all over s squared. Now what do we do in this case? This becomes 2 over x plus 5 over s squared all over 1 plus 7 over x plus 3 over s squared. Now as the limit of x tends to infinity, it means we change everything here with infinity. So this 2 over infinity plus 5 over infinity squared all over 1 plus 7 over infinity plus 3 all over what? Infinity squared. 2 divided by infinity is what? Infinity. It's undefined, so we have infinity plus what? Infinity all over 1 plus what? Infinity plus infinity. Now infinity divided by 1 is what? Infinity plus infinity is 2 infinity. When divided by 1, what are you going to have? Infinity divided by 1 is still the same thing as what? Infinity. Okay, so the correct answer to this question is plus infinity. That's the correct answer. Now, which of the following is not true for a function to be continuous? Now this must exist is correct. F of s must exist. Now f of c is defined, that is correct. Its graph must be broken at c. Then this is wrong. Why? For a function to be continuous, the limit of s tends to c of f of s must be equals to that of what? F of c, rather equals to that of f of c. Okay, so this become f of c. That's when the function tends to be continuous. But when it is not equal to, then that is wrong. So this is wrong. Now let's take the next one. Differentiate, given that y is tan 35x, find dy ds. Now it's very easy for you to find dy ds. First of all, differentiate what you have here, shortcut. If you differentiate 35s, it's going to give us what? 35. Then differentiate tan. When you differentiate tan, what will it give to you? Sec what? Square. Then you write the 35 again, so this becomes 35s. Then the correct answer is 35 sec square what? 35x, and that is option A. What you do, differentiate what you have here first. 35s differentiate, will give you 35. Write it down. Then when differentiate sec square, when differentiate tan, it give you sec square. Then you write the 35s again. So for instance, if I give you tan 2x, what do you do? Differentiate 2s first, it gives you what? 2. Differentiate tan, gives you what? Sec square. Then you write the what? 2x again. Same thing if I give you tan 7x, differentiate 7s, it gives you what? 7. Then we have what? Sec square, then 7s. That's how to go about this using the composite function. You can decide to use that one where we say that let 35x be equals to u. 35s is equals to u. It means the s, or it means, first of all, let's write if we say that, let's write out the equation first so that we know what we are working with. We say let y be equals to tan 35 what? X. Now let u be equals to 35s, so we say u is equals to 35x. Now what will be your du ds? Du ds will be differentiate 35s, what will it give to you? 35, okay? Now if u is equals to 35s, so in this equation we can replace 35s with u. We say y is equals to tan u. Now dy du is equal to what? Sec square u. And you know that your dy ds is equal to du ds times dy du. Why? Because du cancel du, you are left with dy what? Ds again. Now what's your du ds? Your du ds is your what? 35 times dy du is what? Sec square u. This becomes 35 times sec square. What is your u? We say u is 35s, right? So put 35x, and at the end of the day your final answer is 35 sec square 35x. That's why that is the correct answer to that question. Now the next one says find the first derivative of, they gave you y is equals to 3s minus 4 raised to the power of 4. Find the first derivative. Now dy ds, what you usually do, bring this one down, subtract 1 from the power, then differentiate what is in the bracket. So this becomes, first of all, differentiate what is in the bracket, okay? Or let's bring this one down first, multiply this one by what is here. So this becomes 4 times, differentiate what is in the bracket. If you differentiate 3x minus 4, what will it give to you? It will give us what? 3. Differentiate 3x minus 4 to give us what? 3 minus, differentiate 4, it will give us what? Which is 0. 3 minus 0 is what? 3. Okay, so this is 4 times, differentiate what is here, then bracket, write what is in the bracket again, 3s minus 4, and then 4, subtract 1 from the power. That is the shortcut to go about this. So this gives us 12 bracket 3x minus 4. 4 minus 1 is what? 3. That's how to solve a question like that, and that is why the correct answer to this question is option D. This is shortcut, okay? What you do, bring out the 4 down, differentiate what is in the bracket, write back what is the bracket, and then minus 1 from the power. So if I should give you y is equals to, let's say, 2s minus 3 raised to the power of, let's say, 3, what do? Differentiate, first of all, bring the 3 down, so 3, differentiate what is in the bracket. When differentiate 2s minus 3, it gives us what? 2. Are we getting now? Write what is in the bracket again, 2s minus 3, then subtract 1 from the power, which is 3 minus 1. 3 times this is 6, bracket 2x minus 3, then 3 minus 1 is what? 2. Now you can decide to use the long method also. We say our y is what? 3s minus 4 raised to the power of 4. You can say let u be equals to 3s minus 4. Okay, so your du ds is what? Differentiate 3s, what will it give to you? 3. Okay, minus differentiate 4 is 0, so 3 minus 0 is what? 3. Now the next thing is your y will not be what? If u is 3s minus 4, it means in place of 3s minus 4 we can put u, so this becomes u raised to the power of 4. Now what is your dy over du? Dy over du is differentiate 4 u raised to the power of 4. 4 times the coefficient here is what? 4. Then u 4 minus 1 will give us what? 3. Okay, now what you do now is your dy over ds is du over ds times, then you have dy over du. Du over ds is what? Du over dx, where's our du over ds? Is 3. Okay, times dy over du is 4u raised to the power of what? 3. This becomes 3 times, then we have 3 times 4 bracket u is what? 3x minus 4 raised to the power of 3. If I should write this here, 3 times 4 is what? 12 bracket 3s minus 4 raised to the power of 3. And that is why this is the correct answer to that question. So you can use the short method, which just entails bringing this one down, differentiating what is in the bracket, write this again, then subtract 1 from the power. So that is that for that question. Now, given that f of x is equal to 3s raised to the power of 4 minus 12s minus 9. Okay, this is supposed to be minus 12s minus 9. What is the value of dy ds at s is equals to minus 2? Now differentiating this, dy ds will be what? 4 times 3. Okay, then you write the s 4 minus 1 minus, when differentiate 12s it will give us what? 12. Differentiate 9 it will give us what? 0. And this becomes dy ds is equal to 4 times 3 is what? 12 x 4 minus 1. 4 minus 1 is what? 4 minus 1 is, I guess, is 3, then minus 12, because 12 minus 0 is 12. Now what do we do at this point? You substitute in what? At s is equal to minus 2, substitute in minus 2, so this becomes dy over ds is equal to 12 bracket minus 2 raised to the power of minus 3 minus 12, and this becomes 12 bracket minus 2 raised to the power of minus 3 is minus 8 minus 12, and this will become, now 12 times minus 8 will give us, I believe, 96, or let me confirm. 12 times minus 8 minus 96, so this is equal to minus 96 minus 12. Now minus 96 minus 12 is minus 108, equals to minus 108 is equals to our dy ds. So dy ds is equals to minus 108, and this is the answer to that question. Now let's take the next one. Determine dy ds at s equals to 1 and y is equals to 1 if s y square plus 3s square is equal to 10. Now this is implicit function. In implicit function, what you do is you pick out the first one, differentiate, multiply by the second one, and then pick out the second one, differentiate and multiply by the first. So now if you differentiate y, you usually add the y ds to the back. So you have two functions here, two variables, s and y. So what we are going to do now is differentiate y. if you are differentiating y, what you do is to bring s down as a constant. So we bring s down. Differentiate y square. If you differentiate y square, what are you going to have? So it will be s times y square will be what? 2y. Are you getting it? Now I told you that whenever you are differentiating y, you put what? dy ds for implicit function plus. Now we've differentiated what? Y. Are we getting it now? So we want to differentiate s. Now you discover that when we are differentiating y, we brought s down, right? Now we want to differentiate s. What we do is to bring y down. So what do we have there for y is y square. Now if you differentiate x, what will it give to you? It will give you 1. So we have times 1. Now for s, you don't add the y, the s. Plus differentiate 3s square. What will it give to you? 3 times 2 is what? 6 what? X. 2 minus 1 is what? 6s. Everything is equals to differentiate 10. What will it give to you? 0. Okay, and this gives us 2sy dy ds plus y square plus 6s is equal to 0. Okay, now what do we do at this point in time? Make dy ds relate to the formula. Take these ones to the other side of the equation. So this becomes 2sy dy ds is equal to, take this one down and take this one down also. So here becomes, if this one crosses, become minus y square minus 6s. To find the y ds, divide both sides by 2sy. Divide both sides by 2sy. 2sy cancel sy. Our dy ds is equals to minus y square minus 6s all over 2sy. So dy ds at x equal to 1 and y is equals to 1 will be equal to, what will be our dy ds? Wherever you see y, so let's write this out again, minus what? 6x all over 2xy. So our dy dx will be equal to, wherever you see y, you put minus 1. So this minus 1 square minus 6 bracket 1 all over 2 bracket 1 bracket 1. Minus 1 square is what? 1 minus 6 divided by, now minus 1 square is 1 minus 6 divided by what? 2. So our final answer will be equal to, okay, this is minus y square. So we take the negative, okay, y on its own. So 1 square is what? 1. So we still have the negative here. So it will be minus 1 minus 6 over 2, which is minus 7 over 2. So that's how to solve equation like this on implicit function. So this is the correct answer to this question. This is the correct answer, option B, minus 7 over 2. Now this function, if you are given s is equal to sine 5t and then y is equals to cos 5 theta, what you normally do is differentiate s with respect to theta and differentiate y with respect to theta. So taking the first one, s is equals to sine 5 theta. Differentiating s with respect to theta, you write ds d theta. That is the meaning. Differentiating s with respect to theta. Now when you have something like this, what you do first is differentiate 5 theta. Differentiate 5 theta, what will it give to you? It give you 5. Then you will now write the sine. Now if you differentiate cos, first of all you have to differentiate the what? The cos, okay? Now if you differentiate sine theta, what will it give to you? It will give you what? Cos. Then you write the 5 theta. So that is the derivative of sine 5 theta. Let me write it again. Sine 5 theta. What you do first, differentiate 5 theta, it will give you what? 5. Differentiate sine, it will give you what? Cos. Then you write 5 theta again. So that is the s the theta. Now our y is what? Cos 5 theta. Now what do we do? This become dy d theta will be equals to, now first of all differentiate 5 theta, it gives us what? 5. When differentiate cos theta, it gives us what? Minus sine. Then you write the 5 theta again. So this will be equals to dy d theta is equals to this is times, minus times this, everything will give us minus 5 what? Sine 5 theta. Now what we now do here is to find our dy ds. It is usually to find our dy ds, it is usually dy d theta divided by dx d theta. Why is it like that? Because if you invert, becomes ds d theta is equal to what? Dy d theta times this theta comes or becomes what? D theta over what? Ds. Theta cancels theta, so we are left with dy dx. So what we just do now is differentiate dy d theta divided by ds what? D theta, and that will give us dy d theta is what? Is minus 5 sine 5 theta. Then that will be divided by ds d theta. ds d theta is what? 5 cos 5 theta. Now what do we do? 5 cancels 5. You have minus what? Sine 5 theta all over cos 5 theta. And when this cancel, it gives you minus tan 5 theta as your answer. So we have minus what? Tan 5 theta as our answer. That's the correct answer to this question. Now let's take another question. Now determine the third derivative of this. Y is equals to minus s. When you differentiate minus s, you use to multiply this, it will give you the first derivative. The first derivative will be what? This minus, if you differentiate minus s, it will give you minus 1, then e, write the minus s again. This becomes what? The first derivative is minus e raised to the power of what? X. Now it continues like that. The second derivative is differentiate this now. It will give you minus 1 again times this minus here, or let's say, let's take it this way. Let's write the minus first. So it will give you minus times differentiate minus s, it will give you minus 1, then e raised to the power of what? Minus s. Now why are we doing that? If you differentiate e raised to the power of s, it will still give you what? Differentiate this, it will still give you e raised to the power of s. So the only thing we are changing is the minus coming down for each of the cases. So this case, it will minus times minus is what? Plus. So this will give you e raised to the power of s. So the second one is equals to e raised to the power of minus s. Now the third derivative, now this one again will now have to come down again one more time. So it will be minus 1 times e raised to the power of what? Minus s, which is e raised to the power of what? Minus s. And that option is option A. That is the correct answer. So if they give you y is equals to e raised to the power of minus 2s, how do you differentiate this? First of all, minus 2s, when you differentiate minus 2s, it gives you what? 2. Then we have e minus 2s. That's how to go about this question. If you differentiate this again, it will be what? 2 times differentiate minus 2s, it gives you another minus 2, then e raised to the power of minus 2s again, which is minus 4 e raised to the power of minus 2s again. So you continue differentiating like that. That is the same thing that we did for this case. That is the answer to that question. Now determine the value of x at which the maximum point of the function y is equal to s raised to the power of 3 plus 2s squared minus 3 occurs. Now the maximum point is the point at which dy over the x is always equal to 0. Okay, now if you find dy ds equate it to 0, you get your answer. So when you differentiate this will give us 3s what? Squared plus differentiate this, it will give us what? 4s minus differentiate a constant, it will give you what? 0. So our dy over the s is what? 3s squared plus 4s minus 0 is what? Whatsoever that we get here. It's still the same thing. Now we said at maximum point. At the maximum point, our dy ds must be equal to what? 0. So it means 3s squared plus 4s must be equal to 0. Okay, and that will be equal to, now making s equal to the formula, it becomes 3s squared is equal to, this one changing to this side becomes minus 4x. Divide both sides by s squared, divide both sides by, okay, no, divide both sides by 3, rather 3x, divide both sides by 3s to make s stand on its own, divide both sides by 3s. 3s going to here, we are left with 1x here, okay, because there's s squared here. So s will be equals to, this s cancel this s, what are we left with here? 4 over 3. So the correct answer to this question is minus 4 over 3. It occurs at minus 4 over 3 point. Now, the next question that we are having here, what is the point of inflection rather of the function? Now the point of inflection is that point where dy over ds is equal to 0. Okay, the point of inflection is that point where d square y over ds square rather is equals to 0. So our y is equals to s cubed plus 2s squared, then we have minus 3. Now what will be our dy ds? Dy ds will be what? 3s squared plus 4s minus 0, which is 3s squared plus what? 4s. Okay, that's our dy ds. Now the next thing is d square y ds square. What does that mean? It means you should differentiate this again. Okay, differentiate dy ds again to get the square of this. So this gives us 6 what? S plus 4. So at point of inflection, your d square y over ds square must be equal to 0. So what's our d square y over ds square? 6s plus 4. That must be equal to 0. So your 6s, if 4 crosses to this side, becomes what? Minus 4. Divide both sides by 6, and your x is equals to minus 2 over 3, because 2 going to here, 2 going to here, 3. And that is the answer to that question. Now, so I believe that we are done with this session.